Okay, AP Calculus, official book. It's continuity video part 3, chapter 2. Consider the following function: f of x, x plus 3, where x less than or equal to x squared, x greater than 2. We have at 2 defined at 2, then and as we can see here, maybe it's not clear. Here we have point, right? And so if we can see to the left of 2, okay, it's defined at 2, it's defined. To the right of 2 we have hollow point, it's a hole. This is an example of jump. It's jump discontinuity, jump discontinuity, because as we can see continuity, as we can see that the limit of f of x as x tends to 2 minus does not equal limit of f of x as x tends to 2 plus. Okay, example 6. Example 6, as you can see, if x not equal to its x squared, this means limit of f of x as x tends to 2 minus is equal to limit of f of x as x tends to 2 plus. But both, they are not equal to f of 2, because f of 2 is here, right? Limit to the 2 minus is 4, limit to the 2 plus is also 4, but limit at 2 means f of 2 exactly. There's a point here, it's 5. This, we call it a point discontinuity. Point discontinuity. Example 7. Example 7, we can see that limit of f of x as x tends to 2 minus, it's minus infinity. And as x tends to approaches 2 plus, it's plus infinity. So what do we call this? What do we call it? We call it essential discontinuity, right? Essential, we have asymptote at x equal to. So it's essential discontinuity. Example 8. We don't have the figure. Let's see what to do. Okay, this we should do what? We should go and factorize the numerator and the denominator. This is equal, f of x is equal. We factorize it, guess and check, or we find delta, whatever. It's xx. I don't know if this is clear. Let me move down. Okay, minus minus, and it's 3 times 5, right? And because minus 5x, the extremes, that means minus 3x gives me minus 8x, which is in the middle. That's correct. Xx also. Minus times minus is plus. 1 times 5 is 5. And means minus 1x, and extremes minus 5x gives me minus 6x. Also, it's true, we simplify this fraction to get x minus 3 over x minus 1. As we can see, if x limit as x tends to 5, what do we have? Limit as x tends to 5, we substitute for 5. We substitute for 5 in this one here. Here we got limit, let's say limit as x tends to 5 for this function here, for this function over here. It will be x minus 3 over x minus 1. It gives me an answer which is 5 minus 3 over 5 minus 1. That is 2 over 4. It's half. So at 0.5 abscissa half, the original function before we simplified x minus 5, we have hollow at this point. We have hollow, if we draw this function, we have hollow at this point. So it's not continuous, it's discontinuous. And what do we call it? Removable. Removable discontinuity. We remove this point which of abscissa 5 and ordinate half. Let's start with the problems. Problem 1 is the function f of x continuous at point x equal to. First, what is f of 2? F of 2 is equal, we substitute in 6x minus 3. 6 times 2 minus 3, because here we have x equal 2. So the answer will be 12 minus 3, it's 9. Okay, now what is the limit of f of x as x tends to 2 minus? It's in the first one, because x tends to 2 minus means x less than 2. So it's the limit of 2x cubed minus 1 as x approaches 2 minus, which is equal, we substitute instead of x its value 2, 2 cubed is 8, 8 times 2, 16 minus 1, 15, and the limit as x tends to 2 plus is equal of f of x, right, is equal to the limit of 6x minus 3 as x tends to 2 plus 6 times 2, 12 minus 3 is also equal to 9. So the limit does not exist here. We have two different answers, to the right and to the left. So the function is discontinuous. It's not continuous at x equal 2. We have continuity only to the left of 2. To the right of 2, because to the right of 2 is 9, and to the left of 2, and to the left of 2, sorry, to the right of 2 is 9, which is equal to f of 2. To the left of 2, to the left of 2 is 15, does not equal to 9. So we don't have continuous to the left. We have continuous only to the right. So it's not continuous at x equal 2. Let's check also problem 2 before the time finish. Is it continuous at x equal 1? First we start f of 1, right? F of 1 is equal to 6 times 1 plus 3, which is equal to 9. Limit of f of x as x tends to 1 minus, we take this one, which is x less than 1. 1 minus is x less than 1. And we substitute instead of x its value. 1 plus 3 times 1, 3 plus 5, the answer is 9. And limit of f of x as x tends to 1 plus is limit of 6x plus 3 as x tends to 1 plus. X approaches 1 plus, this means a bit more than 1 means greater than 1. So we substitute it in 6x plus 3, and our answer will be 6 times 1, 6 plus 3, it is 9. So we have to the right of 1 is equal to the left of 1 is equal to f of 1, which is all 9. Then it is continuous at x equal 1. Let's see if f of x in part, okay, this will take a little bit more time, I guess, because we are going to find a of, we have condition that it is continuous at x equal 4. It's given as continuous. So we will see you next video.